Are we good to start? Yes? Okay, cool. Okay, cool. Hi guys, I'm Emily. I'm the developer advocate for Linea. If you guys haven't heard, we launched mainnet on Tuesday. Big round of applause. This workshop is not so much about building, but more so talking about where to build and why you should choose Linea, right? I'm not sure where we sit in terms of the technical background from this group, so I'm starting from like ground zero. If you glaze over in the beginning, that's totally okay. But we'll get into something more complex later. So anyways, what is Linea? So Linea will be a type 2 ZK rollup. Right now, amongst the ZK rollup space, no one is actually type 2 yet. I'm going to explain this later, but keep in mind that this is what we are. So starting off, why do we care about L2s, right? So if you've heard of the blockchain trilemma, essentially it's a pick-two situation between scalability, security, and decentralization. Ethereum basically has chosen to focus on security and decentralization. And with like the boom of Ethereum, you guys have probably experienced high gas costs, and transaction times being slow because all of that is like a competing kind of computational cost. So what do? It's something called like a layer 2 solution. We've moved up to something called the rollup centric roadmap. What that means is starting from a layer 1, it's basically the underlying foundation and base blockchain. That's where consensus happens, that where data is stored, the history is there. Examples, Bitcoin, Ethereum, Avalanche, etc. Once we move into layer 2, this is actually what we care about. So layer 2s work by pulling the execution computational, capacity off of Ethereum. The important part to clarify here specifically is that rollups have been the, decided solution because it posts that data back to Ethereum. So if you guys are familiar with like Polygon proof of stake, so you might have heard you have Polygon proof of stake. That's what you know. That's like an OpenSea, etc. versus Polygon zk-EVM, which came out recently. Polygon proof of stake is a sidechain. It is not a layer 2 solution. All of that data is stored within Polygon. So that's why you've seen this pivot towards rollups because it is a much more secure system to leverage the consensus mechanisms and community around Ethereum that like a separate alt layer 1 or a sidechain would have. Anyways, so that's what a rollup is. How does it actually work? So the anatomy of rollup the anatomy of an optimistic rollup has kind of this structure of there's an on-chain contract. So that's going to be on your L1. That stores your rollup blocks. That's where the data is stored. It monitors updates. The next piece is the off-chain VM. So this is where the computational stuff comes. So that's going to be what you hear of the zk-EVM, which we talk about later. And the last piece, I just kind of group them up together, but operators, validators, aggregators, sequencers, you can kind of think of this basically as the entity that takes in all that transactions, orders it, figure out what is going on, and then posts that data back. So moving on, I'm going to name 2 key vocabulary words you need to know when thinking about the different types of rollups, right? So specifically, we have the deposit process. So that's moving ETH from L1 to L2. And then the last piece is ETH from L2 to L1. That's withdrawal. So this actually withdrawal is a key difference, one of the key differences between optimistic and ZK rollups. So let's actually talk about it. So optimistic rollups, you might have heard, Arbitrum, Optimism, huge TVL. They're the first ones to come through. Right? So essentially what they do is they assume transactions are to be valid. So to take a step back, right, like I keep mentioning data availability. What the important thing here when we talk about the different types of rollups is how do we verify that the data we're proving is true, right? So optimistic rollups came around and we say, let's just assume it's true. Basically, we're going to have a 7-day challenge period to wait for the community alongside some slashing mechanisms and incentives to essentially say, hey, this looks fishy. Let me run a fraud proof. If it turns out to be a faulty transaction, that will be rolled back, right? There are workarounds like trusted bridges, but we all know bridges are always hacked. So it's not necessarily the best solution. But anyways, so that was kind of the first iteration of rollups. We knew we needed to do this, but people got smarter. I don't want to say people got smarter. Research took a little bit longer. We got to the point where we have zero knowledge rollups. So how are they different from optimistic rollups? So essentially, they have something called a validity proof. So rather than optimistically assuming, they just say, hey, when I post this data back, I'm just going to also post a mathematical proof to a separate verifier contract that will verify that it's true or false. Something I'm just going to mention, and I always say this, I get a lot of questions about, how is privacy on Linea? That's a common misconception because people think, oh, ZK, private identity, etc. That is a common association, right? Because the property of ZK proofs is that you can prove something without having to reveal the information. What it is in the context of a scaling solution is more so, hey, when we're choosing the different types of mathematical proofs we can use, we're going to choose a zero knowledge proof because that's going to reduce the information as much as possible when we post that data back to be verified. So that was kind of the choice. Examples include Linea, zk sync, Polygon zkVM, Scroll, and Starknet. So I think there's a lot of different layer 2s, kind of, optimistic versus ZK. But once we get into ZK, like what's the difference between all of them? Why do we care about the different kind of pieces? So the first piece, right, I keep mentioning about zk EVM. So essentially this is a zk EVM is the off-chain virtual machine that essentially allows you to execute smart contract transactions in a way that ZK proofs can understand. I can't explain how it works, but basically you can think of it as, I'm writing a computer program. How do I turn that into like polynomials and math that a mathematical proof can actually run and validate? So that's kind of what a zk EVM we've been building, right? And that's the differentiator, one of the differentiators between all the ZK rollups. So this is kind of where I get into the different types. So if you remember that first slide, I said will be a type 2 ZK EVM. At the highest level, type 4, that's going to be Starknet, that's going to be zk sync. You can write in Solidity, but it is not 100% bytecode equivalent. What that means is tools you're familiar with, Truffle, Hardhat Foundry, you might have noticed you need to download a plugin. Not everything is covered, so you got to be really, cognizant about the functions you write, whether or not it's actually supported by that network. You kind of move further down. So type 2s essentially are fully EVM equivalent. So I can write in Solidity, I can write in Viper. It's 100% bytecode equivalent. So the tools that understand the EVM don't need to change at all because there's no difference there. So that's our goal. That is also the goal of the other type 2 ZK EVMs. No one has currently reached that yet, but it's on the way. People constantly doing research and we're like fully confident. And the last piece is fully Ethereum equivalent. Basically, this means every part of the Ethereum ecosystem, kind of structure is used. For developers specifically, there's not a lot of difference in your developer experience. I can talk about this later if you guys have questions about why it would matter, but it's not super important for like a hacker, for example. So last piece, when we talk about like the different types of ZK EVMs, right, the kind of idea is the performance and compatibility trade-off is there. Like building a ZK EVM is very difficult. I think with Starknet, for example, they started off with writing in Cairo, right? Because their assertion was basically EVM itself is like very hard to prove. So we're going to change parts of it to make it faster and more efficient and things like that. I think with the proliferation of type 2s, basically that thesis has been proven incorrect and people are constantly like iterating. So you can also see something like what Starknet now has a new transpiler on top of it that is moving from Solidity to Cairo VM to post back to Ethereum. And I think that is just an indicator of why it is important to maintain that kind of network effect of keeping like Solidity devs in-house, like the Ethereum ecosystem has already been growing and stuff like that. So anyways, kind of like how the prover works at a very high level, you can kind of think of it in linear terms in like 3 different stages, or I guess how many stages are here? 4. So the first part is arithmetization. So arithmetization is basically that part where we turn the computer program into math. So we call this traces. Linea is special because we are the only ZK EVM to actually directly arithmetize the EVM. What does that mean? It means like there's actually slight differences where they have an intermediary VM with the other L2s. But that's super cool tech. I don't want to explain other people's like rollups, obviously, because I don't work there. But the next piece that we do, and this is really what sets us apart, is something called the inner proof system. So it's called Vortex and Arcane. So essentially here, I think diving back into why ZK rollups are really cool, specifically mathematical proofs, is you can apply mathematical proofs on top of mathematical proofs and do that recursively. So you have like this kind of recursive infinite scale. And that's kind of where Vortex and Arcane sits, right? We use something called lattice-based hashing, which is a really interesting thing that is like plausibly post-quantum. What that means is quantum attacks don't exist, but if they were to, we could, set up our system such that it would be, resistant. But no one wants to hack a rollup. They're going to hack the nuclear codes, right? That's how it works. But anyways, it's optimized for recursion. And the last thing is it's really efficient for hardware acceleration, which is kind of something you think about when you think about performance improvements. And the last piece is an outer proof. So that inner proof actually does not get it small enough to be posted back on Ethereum. That last piece is what you might commonly hear as like snarks. You might hear words like Plonk, Groth 16. That's the last piece. It's really cool because you get to basically compress or verify one transaction in 1 billion transactions in the same amount of time. For our ZK circuit libraries, I want to call out, we have an award-winning Gnark circuit library. It's open source. It's actually used by different projects. It is the fastest ZK EVM on mobile phones. So when we start proving things on high schoolers' phones, like, yeah, no, we're there. But anyway, so like, I guess now hopefully you understand this piece. Let's talk about actually what I think, and I think Linea's success so far is really proved by. It's not the tech, it's the ecosystem, right? So private testnet opened in January. I pulled these numbers, I think earlier this morning. 50 million transactions, like wallet addresses, deployed contracts. You can compare this against like Scroll, I think was like 46 million. Polygon, zk-AVM was maybe like the 2 to 3. I do admit there's an element of like having a token versus not having a token definitely drives transactions. But I think there's a lot more to this than like just farmers, right? There's a belief in the ecosystem. And I see specifically, we opened 3 days ago. So we have 13.3 million TVL. For that, what that means, right, if you look in the order of, I guess you could say, all the rollups ordered by TVL, within 3 days, we've jumped from like 0, row 20, to I think now we are row 16, and we are 4 million away from row 15. And so there's a lot of growth, right? And like, why are people really interested in this, right? So first thing, right, finality. Again, that idea of just ZK versus optimistic, you have faster finality, you have a more secure trust assumption, etc. Something you might care about is TVL. So maybe if you're first building, you'll start with Arbitrum just because there's much more like liquidity to act with for your users, right? The last piece, I think that's really compelling, as well as like roadmap when you think about what's next. You know, we're not just what we are now, we are what we are in the future. But I'm going to talk specifically about what makes Linea really different and like why we have onboarded so many partners thus far. And maybe for developers here who want to actually take your apps past the hackathon, why this is important, right? So specifically, it's like if you're building a dApp, you want to make money, right? And how do you make money? You have users. So we are at the same company as MetaMask. We are a default integration. So immediately with Linea, you have discoverability, you have seamless UX. You can think of MetaMask features in the future being set in the home of Linea, right? That's a really powerful value proposition. When you dive into consensus is a little bit of a moat, right? So if you guys aren't familiar with Besu, so Besu is one of the largest open source Ethereum clients. So that means in-house, we have a very experienced team to do interesting things with those kind of performance operations on like the client side for an L2. So again, kind of building on that ecosystem. Again, if you guys are familiar with Infura, like immediately we have that kind of scalability that comes with node providers. And I think the last piece, maybe, if you guys are familiar with Consensus, MetaMask, etc., we do actually have a lot of presence in the Web2 space. So when you think about onboarding people outside of like our little clique of like fanatics, right, who are people going to trust? You know, JP Morgan is going to trust Consensus, right? And I think that's become a very strong value prop that a lot of, like I said, the first 140 applications have been really excited about and why I believe. And also, like, I guess why all those people are there. So the last piece, I guess, is not super important. How many of you guys have deployed a smart contract before? Okay, so I'm going to say like majority of the room. So I don't want to actually go through a full demo, but basically in order to deploy a smart contract, you need a few things. So you need ETH to make transactions for you hackers there who are choosing to deploy. You can get it through a faucet or you can bridge it. I am a bit of a Linea ETH whale, so also feel free to ask me. I can just send it to you. It's only for hackers, so anyone watching this, like, don't send me your like wallet address over Twitter because I'm not going to send you any. But anyways, last piece, right? Like, I think the important part is just, again, you can use whatever you want to use. If you're deploying, I think, like, if you're deploying here on Polygon and Scroll and whatever, like, please deploy to all of us because it's the same experience. Like, you want to amass those bounties, right? So just kind of an example of what it looks like. I can show you, right? Here's my config. Basically, there's Girly, there's Linea. Wow, look, let me write this out. Live coding, woohoo, hopefully this works. I'm going to blame it on the internet if it doesn't. Anyways, Linea. Oh. Do I need to run here? Oh, I have an extra S. Where? Deploys. Oh. Does that work? Nay! Wow, so easy. Okay. That's about all I have. Yeah. This is how you can get in touch with me, Linea Build. This is kind of all of our information. This is a QR code to a website about myself that I haven't updated in quite a while. But yeah, if you have any other questions about Linea and stuff like that, feel free to ask me. Now, I don't know how much time we have left, but am I over time? I talk pretty slowly. Okay, cool. Normally I'm like, whoa, but like I'm tired. We're good? We're good on time? Okay, yeah. So if anyone has any questions, please let me know. I can talk a little bit more about, like, I guess, Linea right now. Another thing, right? When I think about L2s in general, you might hear a lot of the narrative is like, oh, we're so easy for developers, right? But I think it's very much a chicken and egg situation. You want the users for those developers to attract. And so like that developer-friendly experience is just table stakes. I think that's what Linea understands. We want our tech to be there. We want the experience to be there. But what's most important is that when you deploy, people want to use you, right? So we already have something called the Ecosystem Investment Alliance. I hate the name. It feels like Avengers. But anyways, but it's essentially a set of like VCs dedicated to funding Linea projects. I think separately, if you apply for our bounty, there is like an opportunity to get filled into our accelerator program as well. So I think there's just a lot of like interest basically in supporting projects past the hackathon. I mean, I don't know how many of your students, but I don't promote quitting college to build in crypto because I like my degree. But, you know, everyone has their own journey. And if you want to build, the investment opportunity is there. Yes.
Hey, Emily. Could you mention some key protocols that are available in Linea for hackers?
Protocols?
Yeah, like oracles or any kind of protocols they can leverage for their action.
Yeah, so I do really, so if you go to docs.linea.build, oh, I forgot to mention this actually. If you use like our deploying or our, what do you call it, infrastructure partners, we will award bonus points. I think our thesis, right, is L2s are supposed to be boring. In a world where like or what do you call it, like there's mass adoption or whatever, no one knows what an L2 is, right? What makes a dApp robust and interesting is kind of the tooling that's built on top of it. So for example, Biconomy is offering a bounty here. Biconomy launched on mainnet with us day one. And Gaslit transactions are something that's really interesting for like user experience, gaming, account abstraction, etc. So if you want to do like a Linea plus Biconomy bounty, that is an opportunity for you to kind of see what you can build outside of just like, npx, hard hat, run, scripts.deploy without the s.js, dash network, Linea. You know, no one cares about that. I mean, we care that it works, but like, you get what I mean. So, yeah. Oracles. So if you guys does everyone know what an oracle is here? Yeah. Okay, cool. Yeah. So oracles, we have Pragma, Umbrella, Redstone. If you're used to using Chainlink is not deployed on Linea, but there are other options as well. Gelato is really cool. It's another option for gasless transactions. This is notifications. Do you have a question? Oh, sorry.
Yeah. So the native token is Ether.
Yeah, the native token is Ether. So that is like the purpose of a rollup, right? Everything is like Ethereum. Yeah. Oh, you have another question? Stop! I don't know if I can answer all of them.
Yeah, we have a lot of time. We have 10 minutes more. 10 minutes. Yeah, so we asked until the 5, sorry. 5. What is the end game in terms of decentralization for sequencers and so on?
Yeah, I had this in a different thing right here. Oh, okay. So actually, this is something that's really interesting that I think most people don't know. How many of you guys know what multi-prover is? Multi-prover. Okay, cool. The only person who has a question. So anyways, like, that's fine. This is actually when I think, again, like I keep positioning Linea as something really cool, but actually Linea's true value prop, I think, is our commitment to collaboration. So starting off with like what's important with an L2, right, is our roadmap. So we're getting to that type 2, like number one, if we want to say we're type 2 and commit it and say it publicly, we have to be there. So that's on their way. The next piece is like, how do you believe something is secure? So focusing on open sourcing our stack. Right now, we want to kind of keep it in-house, make sure everything's like secure, do all the audits first before like that code is publicly released. That is our next stage. And then yes, like a rollup will not exist without decentralization. Like ultimately, the key of why rollups won over sidechains is security. And if you have a centralized sequencer and no, like, you can have bad actors. Not that I'm a bad actor, but you get what I mean. Maybe I'll leave and then all the bad actors will appear. But the last piece actually is multi-prover. So when we talk about just one, like, proving system, what happens, right? If there's a bug in the prover, everyone's like, I don't want to say F-U-C-K-E-D, right? So the multi-prover theory is actually saying, hey, we have so many diverse implementations of the zk-EVM. And like, that's kind of also where like optimistic rollups have a completely different implementation structure, right? So if I'm passing those transactions through multiple provers to reach like a consensus of truthfulness, that is a much more secure model than like something like just a single prover, right? I think it feeds into why you have like multi-clients on Ethereum with like Besu and Geth and like all these different things, is the diversity is what promotes security. So we are very committed to this. I don't want to throw shade. So I'm just going to say we are very committed to this. So other rollups, if you want to do this with us, feel free. There are. It's in the works. Yes, you have a question. I mean, I guess it could be slower, but I mean, ultimately, okay, yes. Okay, I think it would be slower, but I mean, just like looking at the roll-up space, right? Things are getting faster and faster and faster. And it becomes a trade-off of, yeah, do you care about that versus do you care about like security? And yes. I mean, like, honestly, this is phase 4, so the actual implementation details haven't been decided. It is a very difficult problem to solve, and it requires a lot of coordination. Unfortunately, everybody in the space right now is racing to decentralize. Well, I guess the first part is actually like racing to mainnet, and then racing to type 2, and then racing to decentralization. And once all that is figured out, then like that kind of conversation about like, is it fast enough? Like, is it feasible even? Like, it is a very difficult problem to solve. And those conversations are like happening in the sense of like, we want this to happen together, but not necessarily like we've already committed engineering time to figuring it out. Yes.
Last question. Right, Security Council, do you mean who's running the nodes?
No. It's stuff like upgrades and things like that. Yeah. Right. So right now, everything is under consensus, right? It's decisions are made by our engineering team. But again, that information is public. And like, what do you call it? I don't think any other protocol is at that level yet where governance, maybe Arbitrum's token is what's doing that. I don't know. I can't speak for others, but that's where we are right now. So we are in phase 0, and I don't know if the Security Council has been established yet. I think it's happening. I imagine it will be Besu, MetaMask, everyone in consensus, like stakeholders, external stakeholders as well. Let me rephrase this. The decisions being made right now are internal consensus. The Security Council must include outside actors in order to actually be an effective Security Council, right? So that's where we're at. Cool. Don't ask me any more questions because now I'm sweating a lot. Yeah, thank you.